Welcome listeners again to the second part of our discussion on streams and rivers as the major agent of erosion on the surface of the earth apart from gravity what we discussed under mass wasting. So, the next one is obviously your stream and river which I have been discussing since the last lecture. So, like we discussed about the results of the flume experiment, that how your sand is easiest to pick up during the movement of a river water or a stream, and how your relatively your pebbles and clay particles are relatively hard to transport from one place to another. So, now there is another thing that is also related to this diagram. Again you can look at this diagram. Now, I can simply keep the velocity on one side and diameter on the other side depending on the particle size, that whether it is pebble sized on the right side of the diameter or on the left side of the diameter axis. You will get obviously clay particles in between, where you have this minimum, you can say, distance between or I will say you need the minimum turbulence to lift is obviously the zone of sand, where your sand are getting lifted relatively easier in comparison to the pebbles and getting transported very easily in comparison to the clay. So, in case again if I think about the flume experiment or the result of the flume experiment, that your pebble is getting lifted with high energy, but can be transported with you can say after reaching certain more turbulence or after achieving certain a little bit more increase in the water velocity, you can simply transport pebbles. But on the other hand, if I think about the clay, clay can be very easily lifted, but it cannot be transported unless it is achieving that or it is gaining much of the velocity of the river. So, you need to have a very high velocity of the river in both in cases of transporting clay or in case of transporting your pebble, but relatively you require very less amount of energy, or you can say less velocity in comparison to clay and your pebble. Your sand can be easily transported. So, here also whenever I am thinking about transportation, I will also think about deposition. So, again now if I drop the velocity of the stream, then what will happen? The first one to get deposited, just if I change the velocity or if I drop the velocity a little bit, what will happen? That the pebble part of this diagram will get achieved here just by dropping a little bit of velocity of the river. So, in that case what is happening? You are depositing your large size particles like pebbles or cobbles. Obviously, beyond this there will be boulder. So, they will be deposited first when we are talking about in terms of deposition. So, they will be deposited first, followed by the deposition of obviously sand, like here the sand will get deposited, and finally your clay particles will also get deposited when the energy level or the you can say velocity reaches its minimum level, then only you can deposit clay. If it is at the intermediate velocity you are thinking about, you can only deposit sands. If the velocity of the water is pretty high, then you can deposit pebbles and cobbles or granules. But in high velocity what will happen? Both your sand and clay particles will be moved further away from the zone of deposition of your pebbles or granules. Then subsequently your sand will get deposited. Finally, when the velocity of the water is minimum or it becomes kind of a near lamellar flow, then your finally your clay particles will be settled. So, I can say that clay particles can be transported to your larger distances in comparison to your sand, or obviously there is no question of a large transport of a boulder or cobble. So, there will be always relatively less transport in case of your pebble or cobble. There will be a moderate transport in case of sand. Maximum transport can be achieved when your particles are mainly your clay size particles. So there are two terms commonly used whenever we are talking about the transport of a material through a stream. So the load and capacity of a river. So rivers can only carry so much load depending on their energy. The maximum volume of load that a river can carry at a specific point is its in its course is called the river capacity. So here I would also like to mention that there is a small difference between load and your capacity. So the maximum volume of load that a river can carry is your capacity of that river, but the amount of volume of load that a river is carrying is the load of that particular river. So you can see there is a distinction between can and is, and that is quite important. So the maximum value of load that can be carried by a river is your capacity of that river. The load or volume of material that is carried by the river is the load of that river. So there is a small distinction again between load and capacity. Apart from that, you have the competency of a river. Rivers and streams carry sediment that ranges in size from clay to boulders. The competence of a river or stream refers to the largest particle that a river can transport. So if a river is transporting and depositing boulders and cobbles and granules, you can say that the river is very competent, that it can even carry large size particles or large size sediments along its course. But finally, if a river reaches maturity or it's in older stage, obviously the competency of a river is reduced. So in that case, it will be only able to carry you can say dominantly mud and obviously some sand along with it. So again, if I take the reference of Ganga, near your Gangotri region, you can see that it is transporting large size boulders, cobbles, obviously granules in the river. But if I again go to the near Bay of Bengal or at the Ganga Brahmaputra delta, there you will see that the particles or the material that is being transported by the Ganga river is purely muddy in nature with some sand in it. So simply by looking at the type of particle a river is carrying at a particular zone or a particular reach, you can have an idea or you can analyze its competency, that whether it is highly competent river or it is or it has lost its competency during its long way of travel from its initial place of origin to the mouth of that river. There is another important aspect that we already discussed in our principles of stratigraphy, but again just to mention the base level of erosion. So there are again two types of base level. One is the temporary base level, the other one is the permanent base level, like we discussed. So if you have a lake in a region, in a, for example, again relatively higher elevated area, if you have a lake, then the water level of that lake can be considered as a temporary base level with respect to that region. That means you can have an erosion till that level. Beyond that, you can't erode materials beyond that or beneath that. So in case of the permanent base level, obviously permanent base level is nothing but your mean sea level, which is also referred to as the ultimate base level. So beyond the mean sea level, you can't erode materials, apart from a few cases in glacier where there are example of fjords. So fjords are nothing but they are some glacial erosional glaciers that can erode beyond or even below the mean sea level. So that what fjords are, we will be discussing about that in our consecutive lecture when we will discuss glacier as an agent of erosion. So you have this permanent base level, it represents long term control over erosion, typically the sea level, and it determines the ultimate landforms and channel profiles, whereas your temporary base level, which is for example the water level of a lake, it fluctuates due to factors tides, dam and other temporary obstructions. And example include tidal fluctuations affecting coastal streams, damming or altering river profile. So there is a distinction between obviously local base level with respect to a specific region and the ultimate base level, which is referred to as the mean sea level across the globe. Now, just to discuss a little bit about the Davis humid cycle of erosion. So, the concept that was put forward by Davis, that there are sequential changes in landforms through time, obviously when the river is flowing from its initial zone of origin to the mouth of that river, and these sequential changes are directed towards well defined end product development of peneplain structures. So, the basic assumption that he took to propose this idea or concept, that landforms are evolved products of interaction of endogenetic forces and exogenetic forces. Then that means endogenetic forces means the forces that are involved in the movement of a stream. Exogenetic forces, like for example, you have created a dam somewhere, or some, you can say, some pooling, natural pooling of some water is happening somewhere. So, that are your exogenetic forces that are responsible due to a landslide. Some river pooling is happening somewhere, because you are restricting the flow of the river in some part of the channel, and there is a natural pool that is getting developed. So, the evolution of landforms takes place in an orderly manner in such a way that a schematic or systematic sequence of landforms is developed through time. Streams erode their valleys rapidly downward until the graded condition is achieved, and erosion does not start until the upliftment is complete. So, here again you can see there is a graph that reflects the different stages of a river. This is your altitude or elevation, and here how your youth stage is getting modified into the mature stage and your old stage. So, you can see that the base level, this base level is nothing but the ultimate base level. So, in the uplifted region, or to the, means near the place of the origin of that river, you can see that the base level has to be local in comparison to the ultimate base level. It is much at a higher reach. It has a very high altitude in its youth stage. In case of maturity, generally it will fall in its altitude, as well as the length of the channels will increase. At the finally your old stage, the length of the channel or you can say the sinuosity of the channel will also increase, leading to an old stage of this river. So, this is a graphical representation of Davis's cycle of erosion, and you can continuously see a change in the uplifted slope, the slope of the river, also elevation of the river is continuously changing from its youth, mature to its finally old stage with time. So, in youth stage, the valley deepening is the dominant process, because the channel gradient is very steep, increase in the velocity and kinetic energy, increase in transporting capacity, and valley incision is also high. In the upper reaches as well, there will be valley deepening always, and relative relief continues to increase until the maximum relief attains at the end of the youthful stage. So, the valleys will be mainly like this, V-shaped gorge or canyons will form when it is in the youth stage. So, the characteristic features of youth stage of a river is V-shaped valley, rapids, waterfalls, no floodplains, drainage divides, and valley will get deepened with time. In mature stage, you will see some characteristic feature, that there are marked lateral erosion and well integrated drainage network, or graded conditions spread over a large area. Valley deepening is remarkably reduced in comparison to that of the youth stage. Summits of water divides are eroded, and there is a marked fall in the upper curve like this. This is the lower curve, this is the upper curve. So, there is a marked fall in that. Valley widening transforms V-shaped value into wide V-shaped. Means in case of a youth stage, you will have valleys that are like this. In case of matured one, you will get V shapes like this. So, you can see there is a change in this angle of V. In later stage, the upper summits are rounded off. So, substantial decrease in channel gradients, flow velocity, and transport capacity. Appearance of flood plains will start. So, Here in the mature stage, there will be some presence of some flood plains. Then in the mature stage as well, there are two subdivisions. One is the early mature stage, another is your late mature stage. So in the early mature stage, you will get V-shaped valley, beginning of your floodplain, sand and gravel bars, sharp divides, valley stops deepening. So there is no more formation of any gorge or very deep valley. Relatively, the depth of the valley will decrease. And then in the late stage of a mature river, again valley has flat bottom, narrow floodplain, divide begins to round off, relief will decrease. That means the change in the altitude will be minimum in comparison to the youth stage. The relief changes very quickly, means there is a distinct change in the elevation, but in the case of a mature river, this change in the elevation is pretty small. So your relief diminishes, sediment builds up, floodplain widens and rivers begin to meander. That means it will gain some sinuosity along its course. In the finally old stage, the valley incision is now stopped. So there will be no undercutting of the valley, there will be generation of floodplain. So the water will now pour on the sides or on the lateral, or you can say the margin of a channel. So valley incision is now stopped, valley will start widen, rapid decrease in absolute relief due to erosion. Obviously erosion will be also more, because now you are no longer eroding material only in the channel, you are also eroding material along its boundary. So the valleys become almost flat, broad, open and gently sloping, rivers are extremely meandered and monad rocks are seen. The entire landscape is transformed into a peneplain and graded conditions will prevail until there is a rejuvenation. We will in our last part of this discussion, we will be also talking about rejuvenation of river. So features that are formed in old stage, like land worn to nearly flat surfaces, which are also referred to as peneplains. Resistance rock remain as erosional remnants, and river meanders across extremely wide flat floodplains will start. We will talk about different landforms in the third part of our discussion on stream and rivers in our next lecture. But here just to mention that meandering rivers are again very characteristic of a old stage of a river, though meandering start from the mature stage, but you can see the different landforms related to a meandering river, and that kind of features you will mainly get in case of an old stage river. Finally, a river rejuvenation. So some changes might cause the stream to steep up and cut deeper. So this is referred to as the rejuvenation of a river. So uplift of land, lowering of sea level, greater stream flow might induce this kind of a change. Stream valley takes on youthful characteristic but retains features of older stages as well. So you can see when a older river is again is gaining some characteristics of its youthful stage. So there will be deepening of the valley, again there will be mainly downcut of the valley will go on. So material will be eroded at a faster rate, and also the turbulence within the river will increase, and that will result into the again some deep valleys or small small angle valleys will start to develop. So this can happen at any point in a cycle of this complete from youth to your mature stage and finally old stage. This can happen within at any stage. So the best example of your river rejuvenation is from your Colorado River that forms the Grand Canyon, that is the most beautiful canyon feature on the surface of the earth. So the Grand Canyon's formation is a result of million years of geological processes, primarily the erosion caused by the Colorado River and its tributaries. So there has been a geological uplift. The process started around 70 million years ago, when the Colorado Plateau on which the Grand Canyon sits began to uplift due to tectonic activity. This upliftment created a high and flat terrace like you can see in this photograph. So there you can also see there is a deepening of your this Colorado River with time. So the upper one is the lower one is even deeper than the means the Colorado River flow is even getting deepened in the second photograph. So your river erosion around 6 million years ago, the Colorado River began carving its way through the plateau, slowly cutting into sedimentary rock layers that were already present. The force of the water combined with sediment and debris carried by the river acted as a powerful erosive force. So the Grand Canyon formed over a million of years. The river continued to erode deeper into the layers of the rock, creating the immense canyon that we see today. The Grand Canyon is not just a single gorge but a complex system of interconnected canyons with cliffs, ridges and other geological formations. Rock layers, the Grand Canyon exposes nearly 2 billion years of Earth's geological history in its rock layers. So you can see that this kind of river rejuvenation can also add up to or can give you much more information than simple you can say simple history of a stream flow or a simple history of a river. So if these rivers get rejuvenated again and again, then it can cut through further beneath the earth or beyond the present earth's surface. It can go deeper and deeper, and it will expose the rocks that are present beneath the exposed surface of the earth. So this continued erosion is an ongoing process in the Grand Canyon. However, the erosion rate today is much slower than the initial carving or what happened during the initial rejuvenation. So this is possibly the best example of a rejuvenated river on earth. Before finishing the second part of our discussion, I'd like to mention that rivers do play a significant role in shaping the earth's surface through erosion, transportation and deposition of sediment. These processes result in various landforms. So next we will be discussing in the third part of our discussion on streams and rivers, we will be discussing about the different landforms formed by river. So you can see a beautiful photograph of your erosion by river. You can see deep valleys, gorges formed here. Then you have the transportation, obviously the material is getting transported along with the river, and finally the river is depositing the material to its mouth, and these regions, when the mouth is finally onto a sea or an ocean, there it forms deltas. We will be talking about that as well in our third part of discussion. So here I would like to conclude the second part of discussion on streams and river. Thank you.